Alright, so let's begin with today's class, Bash scripting. Um, so here we have talked about two different scripting languages. The first one was Python. We have learned about Python, the classes, the object-oriented methods of it, the different modules that you could use, Lambda functions, and a whole bunch of things. High-level programming. If you want to just automate the things that you are trying to do on Linux, Linux has got its very nice utility called Bash, using which we could provide the kernel the commands that has to be automated. We could write everything into a small script and the script should take care of automating each command for us. Of course, everything has to be tested manually first and it should work without any human interaction. Okay, so Bash comes to rescue. Actually, there are different shell level utilities. There are different shells. Bash is just one of them. So the utilities that are available in the market, that were rather available in the market, Corn was there, then there was C shell. Now these days we use two of them, which is shell and bash. Bash is just an advanced version of sh utility. So it's called Born Again Shell, Borne, Born Again Shell, which is a mix of corn, C shell, and a few features from shell itself. So it's an incremental product. These days we have got shell and bash both present on the machines. So if you check, if you open up a machine, let me bring it up. We are going to spin a box. Okay, so there are going to be both these utilities present on your machine. Anyways, which ones do you use? You'll have to very specifically say that you are going to use bash and not shell. The reason because we have many advanced features here, and if you try to run the program in shell with those features, it wouldn't support it. So that's very simple. So we need to specify that we'll be using bash. So what is the positioning of this shell thing? Actually, we have got hardware, right? On top of hardware, we have a layer called kernel. Now this kernel is responsible for handling all the hardware requirements or passing the instructions to the hardware for execution purposes. On top of the kernels, there would be a few utilities called as system utilities. Utilities. Okay, so we have got utilities on top of kernel. Now, the system utilities could be very small commands like ls, cd, some interfaces that allow us to interact with the kernel. Okay, so using these system utilities and kernel APIs, we build a small interface. Now, this interface, which allows us to interact with the kernel and system utilities, is called shell. So shell is not directly provided by the operating system providers, but they are happy to bundle up the things for us so that we could easily use it. So shell is a completely different project. System utilities are built along with kernel. So they are also called as system built-in commands. And kernel talks to hardware. System utilities also talks to kernel. So using this shell, the black and white screen that you see, that is shell by default. Okay, so when you are able to type the commands, you are actually typing the commands on shell. The users would be interacting with the shell. Now here there are two ways of interaction. One is um, interactive mode. Another one is uninteractive mode. So in interactive mode, we write our own commands. In non-interactive mode, we don't. Okay, we just write a script for that, or maybe there is a command which does not require any human interaction for execution. maybe some program execution or something like that. That's called non-interactive mode, and we will be looking at both of them. um, we already have seen an example for that, rather. If you remember passwordless authentication, we were trying to set up passwordless authentication for Jenkins slaves. So that passwordless authentication is actually a non-interactive mode of running commands. Interactive mode would be when you are asked to type in the password and it requires some human interaction with that. So let's see how shell would help us in leveraging all of these automations at some point. Of course, it is not a high level language, so do not expect much from that. So this is my machine, which I'm going to show you how shell would work. First, I need the IP address of it so that I could connect to it. Okay, again my SSH client that I generally use, and connect to this machine remotely. There we go. I'll increase the font a little so that it becomes more visible. Okay. So you must have seen multiple commands. Okay, we every day keep on firing some commands on the system. Now those commands are actually scripts. Okay, they either could be compiled scripts, they could be just textual scripts, but they are scripts at the end of the day. Okay, so there are multiple instructions that could be written inside of it. Shell takes care of executing those or passing those things and instructions to the kernel for execution. So shell is just an interpreter in that case, or rather you say it's a kind of parser. So the commands that are present inside the system are called as shell built-in. And we could find that using the type command, I guess. Let me find it. Type of ls. Okay, see, it says ls is alias to something. Type of cd is a shell built-in. What about chown? That's another command, right? It is present in the file called bin chown, so that is not shell built-in command. What about useradd? Okay, so useradd is again a utility which is written in this particular file. And if you see the file bin present into binary as bin or sbin, it is going to be a binary file rather than um, a textual file. So you cannot modify anything inside of it. Then there is touch. Touch command is also provided as a binary file. So there are multiple commands. Most of them would be not part of the kernel or shell. They would be the external ones. The internal commands are cd, then ls, and so on. So the commands that you need in day-to-day life, most of them are provided by these operating system providers as the binary files. So if they could do that, we could also write our own commands if we want to. What we could do is um, we could create a script, make it executable. So there are multiple ways of executing the script. I'll show you all of them. So very first thing is how to write a small hello world program, very small one. So I'm cleaning up all the mess from here. Okay, that's empty. We are going to write a small program. So I'm creating a file. called example.sh. Why sh? Because we are going to execute it as a shell. I'll show you that extensions are not mandatory here. Extensions are not at all mandatory. Now, I'll write hello world inside of it. We know that if you echo something out, echo is a utility on Linux. If you echo something out, you should be able to see it on the screen. Echo hello world. Okay, so anything you write inside of a bash script, it is treated as a command. Only in a few cases where the line starts with a keyword in bash, it will not consider that as a command and would take care of executing it line by line. But otherwise, if there is no keyword falling on that particular line, in that case the line is treated as a command. Always remember that. So I saved the file. How do I execute it? For executing the bash script, you could type bash, just like in case of Python, we type Python space the file name. Here it is bash space the file name, and you'd be getting the answer. Now echo is an external command. It is not a part of bash keywords. I could type in echo directly here and get similar results. So if that is external command, even bash can execute it, or if I want to execute it using a shell, shell can also execute it. So that's fine. That's very primitive thing. But if I want to very much specify that I don't want to execute it using sh, but I want to execute it using bash always. So that's the way to do that. And if you see, I have fired the command using bash and then example.sh. Generally, when we write commands on the console, we don't write bash at all. Have you seen writing someone like this? Bash cd or bash useradd, even if those are files? No, we haven't, right? So there is no requirement of providing the compiler there that please use bash compiler for doing this. Rather than that, what we do is we add a line, okay, a shebang line to the script. So the first line is called shebang line. If you start it with a hash and an exclamation mark, not just hash, only hash means a comment. Hash and exclamation mark would mean that it is a shebang line. So I would say use bin bash or use the bash for executing this particular file. But how do I know where bash is? So there is a command called which. Now this command would tell us where that particular file is kept. If there are multiple versions of it, which of these versions is going to be picked up? So let me first show you that there are multiple versions of the same file where user add. Okay, sorry, where is user add? So now you see that user add is present in two locations. The default package would be is a gz package kept at man. Then we have user add as a binary utility kept at user as bin. Similarly, for the other ones, chmod, where is chmod? It says that chmod was placed in two different packages, and we are using the binary file from the location bin chmod. Fine, but I don't want to know where it is. I just want to know which one are you using actually. So I say which bash or which chmod. It would give me one single answer that this is the binary that we are using for firing the commands. Alright, so give me where bash is kept on my machine. bash. Okay, so it says your bash is present at bin bash. Alright, so in the bash file that we are writing, remember the path is bin bash. We would be writing our own shebang line, hash, exclamation, bin, bash. Okay, it is hash, exclamation mark, slash bin, slash bash. So if I write this, I don't have to use bash again. Okay, for that to work, I need to first make the script as executable so that it executes itself as a command. the permissions that are present on this the script currently, it's not executable. It's only allowing the read permissions for others and groups. For user or owner, it is read and write, but I want to make it executable, so let's change the permission of it. Chmod plus X, change the permission for all. If you want to change the permission only for the owner, you could change it like this. Rather, U is for owner, G is for group, O is for others. If you want if you want to change it for all of them, you could be doing like this. So chmod plus X, example.sh. Let's check the permissions. Okay, so it says now this file is executable. How do we execute it? There are three ways of executing the file. We have seen the first one, bash example.sh. That's one way. Another way is to use relative path. So currently I'm in the folder where example.sh is. So I would be executing it relatively using the relatively path. So I would say dot slash, that means the current folder, example.sh. So in my current folder, there is a file called example.sh. Go check what it is. So since the file is executable, it would be executed. If the file is not executable, it will not be executed. As simple as that. Okay, what's the another way? Another way is to uh, use the relative, not relative path, but the absolute path. So absolute path always starts from the root slash, right? So slash, whatever your path is. In my case, it is home, my username, and the file. So here we have used absolute path for running that script. Now there is yet another method in which you could execute the script. For that, you'll have to add that script to the path. If you are from Windows background, you know that for running Python, we have added the Python. We'll have to add the Python path or folder location in your environmental path settings. Okay, and once you add that, you should be able to use the utility all across your folders and directories. Similarly here, that I know where bash is kept. I'm able to use bash even if I'm not at the same path. I'm not typing /bin/bash here, just bash. So how is Linux able to figure out where the bash is kept and to execute that? Well, there is a variable called path, and this path is actually a string, concatenated string that holds different directories where your binaries or scripts are supposed to be placed. If you want to add your own, you could also add your own to this list. Okay, so what I'll do currently is I will add my script in one of these paths. So since it is a custom based script, we would be adding it to user, and it is just a source code, so I would be placing it in sbin. So it is user sbin. Is there a directory like that? Yeah, user sbin. So we are going to place our file in this. So what I'll do is I'll simply copy the file example.sh and place it inside user sbin. Oh, sorry, I moved it inside share. Never mind, that would also work if it's in the path. No, that's not in path. Sbin, user sbin. So copy your file there. Now if you hit example.sh, you would see hello world. So whenever you type a command, it is actually searched in all of these locations first. If the command exists there, it would be executed. Otherwise, command not found error would be thrown out. That's fine. But have you seen any of the command with extensions? No, you simply type in bash. You simply write chmod. You do not type chmod.sh. So what we'll have to do is we'll have to modify the extension. So the extension of this file, let me change the extension. The file will be kept at user has been, and the file name is example.sh. Now let's move this file to the same location but with another name. So that's renaming. User has been example.sh. I don't need the extension. So extension is not mandatory here in bash. Okay, as long as the file is executable and file knows which compiler to call using the shebang line. So can I simply type in example and get my results out? Yes. So you have just converted your shell script into a nice bash command. Very simple. Now we are going to learn about how to use variables and constructs inside that script so that it becomes more flexible and we could use it for different purposes. Currently we know how to use it as a command, how to use it as a script, okay, how to execute it using 3 or 4 different patterns. So what we are going to do is we are going to learn about a little about a general language. So since bash is a scripting language, many of the constructs are very similar to other languages as well. So there are variables, there would be some control structures, there would be some loops, okay, case statements. There are no classes. This is not object oriented language, so all your object oriented programming concepts are missing from this language. It's very common structural language here. So let's do one thing. I'll open up my example file. Rather, I'll remove this from this location. We don't need it. rm from user has been example. Okay. So I'm removing the command. As soon as I removed it, we are not able to fire example. It says no such file or directory. Fine. Open up our file example.sh. Now again, like I said, sh doesn't count here. I could rather change this name to example.jpg and execute that file. Doesn't matter at all. Okay, the extensions do not count. Extensions are only required for identification of the file, that where this file belongs and what should be used for executing it without reading the file. But inside the file we have very specifically mentioned that I want to execute this file using bash, and that's how bash is able to figure out what has to be done. Okay, so that's my file, and I'm going to drop in a few constructs inside of it. Like I said, every line is a command except that whether it is containing a keyword or not. Okay, so we'll see some examples of variable declaration, but I would like to take a small break here. There's something I need to take care of, right? So till then, I'll take a small break of 5 minutes. If you have any queries or doubts till then, if you are pondering over something, make sure that you ask it in the chat boxes or keep your questions ready. It's 8:30 a.m. here on my clock. I'll be back in exactly 5 minutes. Alright, so I'm back. Any doubts or queries? I don't see any. So let's move forward. We were talking about the variable thing, right? So to define variables, it's a very simple thing that anyone could be very familiar with. Write a variable name. We have already done that with Python, right? So var here is my variable. It's not a keyword. So this variable would be containing some value. I would say please hold the value hello world for me. Okay, very straightforward. Variable, then assignment operator, then the value of it. Now always remember that uh, bash is very critical about using spaces. So if you add a space here, that variable declaration is nullified. It is not considered to be a variable then. It is trying to use that single equal to signs as an equality operator. Okay, single equals to with spaces is equality operator. Single equals to without spaces is assignment operator. So always remember that. So I simply created a variable. If I want to use it again, for using it, you need a dollar sign added before the variable name. While defining it, you don't need to do that. While using it, you'll have to use a dollar sign before the variable name. So I'm going to save this and we are going to execute it just like the previous one, and then you get the answer. So what's different here is I can now change the variable value to anything and EchoVar should be able to take care of it, right? Is there a way to change variable values dynamically? Yes, there is. We will see how to change it using the parameters that we pass to the script. So I could pass any of the parameters to the script and script should be taking care of evaluating that for me. Now the variables could be of different types, different data types rather, and all these data types are handled internally. So you don't need to specify that the variable is of type int. Okay. What are the rules for variable names? Very simple, the same thing that we have learned in Python. Should not start with digits, should not start with a special character, should not have any special character inside of it, can have underscores, cannot have spaces, can have digits inside of it. Okay. Uh, but one thing is actually it's not mandatory, but it's just a standard that variables, when you write them, variables are written in capitals, all caps, in Bash. Okay, so that's the usual standard that people follow here in Bash. So here, if you type in var equals to 123, it would be integer. If you type in var equals to 123.0, it would be float. If you type var equals to abc, that is going to be string. Okay, and you'll have to make sure uh, to figure out what the particular type is before operating on it. Or there are ways to specify that whatever is coming in should be treated as a number. So that's an expression that we are going to evaluate. We'll see that see those things in a short while. So let's write a small code here. Whatever you are able to type in on your console, the black and white screen, you can automate that. So currently what I want to do is I just want to create a small backup file from any of the folders. So let me check whether we have a folder ready for that. Folder should be having some files inside of it. Okay, so let's take an example. Let's take a backup of this example file itself. So for taking backup, we generally use the zipping utility called tar. Okay, so what we could do is let's say the output package. So I would say the output package name. We are giving the output package some name. The name would be should be kept at this location. I'll rather keep it at temp. So I'm adding my output package here, and the output package should be having some name. Now the name could be a dynamic name because every day if the script executes, I should be able to get different files, different named files, and there is no one to take care of it. So let's do one thing. I need a file named backup underscore, and that backup should be having a tag to it. Okay, so tag could be a year, month and date kind of thing. So let's do that. Now dollar and parenthesis helps you to fire command inside of a command. I'm firing the date command with a parameter that please give me the date in the format YMD. Okay, and the package should end in tar.gz. Okay, so that's the format of my output package name. The command actually is something like this: tar czf to generate the tarball. Generate the tarball from this folder, okay, and export it to the location of output package. Since I'm using output package again, we should be placing a $sign before it. So that's the command. I could also fire both these lines directly on the prompt, directly on the command prompt, and those should work. I just want both of them to be executed at once, so I'm writing a small utility for that, a file inside which I have typed in these commands. So save it, try to execute this now. Okay, so let's check at temp. Do we have the folder? Yeah, the folder is present. So sorry, that's not a folder, that's the package. .tar.gz package is present with a name backup underscore and today's tag. So if I had execute this command tomorrow or day after tomorrow, or maybe added to a scheduling utility called cron to execute it every day, in that case we would be getting different tags, different days. So we should be able to easily identify that okay, this file was created on so and so date, right? So makes our life more easy. RM backup, okay. Since we are talking of variables, there are two different kinds of variables depending on the scope. So local variables and global variables. We have seen in Python that all the variables that are defined inside the function has called a local scope. We cannot access them outside the function unless and until they are passed by references from outside itself. Or we use a global keyword for identifying the global variables inside the function. Okay, but what about Bash? Bash supports the same mechanism, but it supports it exactly in the opposite way. So all the variables which you write inside the function are global by default. They are not local by default, they are global by default. Okay, so accessibility is all through the script. So it's all up to you to specify that the particular variable should not mess up in the outer space, and that's local to the function. So let me write a small function here. Function starts with a keyword called function, not with def, it's a function. Then I write the function name is modify. Okay, you don't need to specify parentheses here in a general function. You don't need to even pass the parameters. I'll show you how to do that in a while. So this is the simplest function definition, where function name, function keyword, function name, the block starts with curly brace, ends with a curly brace. Okay, now what I'm going to do is I need a variable var in here to be holding some value for me. I would say the value should be 2. There is a variable outside, the same variable outside the function holding value 1. Okay, so what I'll do is I'll try to echo $var, then give a function call. To call a function, we give the call just like in case of a script, as if it was a script. No parenthesis required again. And then I give a call to var again. Okay, so let's try if it works. How do I execute it? Dot slash example 1 and 2. Okay, So it says that initial echo before giving a function call had a value of 1. Then I gave function, then I made a function call. Inside that function, we modified the value of var and we have assigned the value as 2. Then outside the function also, the var has changed, right? Echo statements are outside the function, so the reflected value should not be getting outside. But it is because the default behavior is global in Bash. It is just opposite in as of in other languages. To make it local, I have a keyword called local. So I could say local var equals to 2. In that case, let's try to execute the code again, and this time we should be getting the answer as 1 1 instead of 1 2. So the change that you made inside the function now is local to that function by specifying the keyword called local. Alright, so you'll have to take care of it. If I want to make my function more flexible, um, I could take the values or the dependent values, environment values from the console. Okay, since everything is hard coded inside a function, we have a way to modify it just by using it a variable and assign the value to the variable to be something else. So I could have something like this. Let's say we want to simply echo the contents of the file. Okay, not the contents of the file, we haven't looped yet. um, I just want to echo some variable var equals to 123. This is what we did, right? And then we tried to echo var out, so that works. But if I want anything that is passed by user to be echoed out, in that case we need to modify this. So I would say $1, which is the first parameter, $2 would be the second parameter, $3 would be the third parameter, and so on. So what is $0? Anyone? We have seen that in Python, that the first parameter would be on the first index. So what's present at index 0? Anyone, any clue? Okay, so $0 is the file name itself. At 0th index we have the file name. At first index we have the first parameter. Second index we have the second parameter, and so on. Okay, so if I type something like this, can we make it more dynamic? So example, if I pass ABC to it, it would be printing ABC. If I pass XYZ to it, it would be printing XYZ. If we pass multiple words to it, in that case it will not be typing multiple words. So the reason why, because beta is actually $2, a second parameter, alpha is $1, which is the first parameter. Okay, so that's how you'd be passing the parameters to the function. Let's echo $1, $2, $3, all three of them. Now these are actually the arrays. You could loop over all these arrays if you want to. Let me show you that it works. Alpha, beta, gamma, delta. We would be looking at alpha, beta, and gamma because delta happens to be $4. If you want to access all the parameters at once, you will have to treat the parameters as arrays, and there is very unique way, or rather a complex way of accessing arrays in Bash. So if 1, 2, 3 are indices and I want to access all of them, add the red sign. Add the red sign means everything, everything that is present inside the array. And now you get all the fold parameters, alpha, beta, gamma, and delta. Dollar, add the rate. How do I know how many arguments are present in that? So I could say echo count equals to, place it inside a string. Count equals to the count, whatever the count is. So it is dollar hash. So hash would give you the count. Okay, ampersand would give you all the elements at once. If you want to very specifically access a particular element, you will have to pass the indices of it. Okay, so here in this case, the array does not have any name. That's you might have already guessed that there is no name given to the array. The array without any name is the parameter array. If you want to give it any name, in that case you will have to assign it to some third variable. Okay, so how to assign it? I could do something like this: assign it. Okay, you don't have any multi-line comments here in bash. All you have is single line comments which starts with a hash sign. Do not add an exclamation mark because that is going to be a shebang line. Shebang line should always precede any of the execution steps in your scripts. That should be the very first line. Okay, so I would say this is a comment and we are trying to assign parameter to array. Even arrays are not so fancy arrays. We don't have any associative arrays here or dynamic arrays here. We just have 1D arrays which can be easily used to satisfy all the requirements at bash. So how do I write array? So args is my array, or a variable rather, to which I want to assign a value which is coming in from dollar @. That means all the values from this array should be assigned to another array called args. How do I use it? Echo. If you want to print all the arguments in args, in that case it's a little bit complex. Since now we have the array name, we would be mentioning the array name, and in the square brackets we would be mentioning all @, all the elements. If I want the count, in that case the count would be given like this: echo count equals to dollar. Again it has got a name, so the name, count of how many elements, all the elements, but the count is given by a hash sign, so place a hash sign before the names. So let's see if it gives exactly the same result as above. Yeah, so this is the result from the parameter array. This is the result, the lower result is from the custom array that we defined from the parameter array. Okay, things can very fast become complex here because everything is new. All the syntax would be new. You haven't seen these kind of things earlier. So now we'll see a little bit into how do we fire the shell commands with bash. So far it's okay. If you type anything on the line, it is considered to be a bash command. It's really fine. But if I want to use that output somewhere else, okay, so let's say there is an output which is coming in from ls command. Everyone knows what ls is used for getting the content of the directory listed. If I execute this, I would be getting some answer like this: backup cache crash lib. This is output of ls/var. Okay, but instead of just showing the output on screen, I would be more interested if I could store that output in a variable and then use it for some purpose. I don't know which purpose, but just some purpose. So what I could do is I could write a variable var, and ls output should be stored inside var. How do I do it? Backticks. So backticks would be making sure that whatever you are typing is contained into a buffer, and you could use that buffer to assign it to some other value. So in this case, my variable var would be holding the output here, so I could easily say echo $var to get the value out. Sorry, not this. It is dot/example. There we go. Okay, so here all the values are stored in another variable. Now if you see closely, the first output that you received by directly hitting ls/var is different, a bit different than the values that are stored in a variable now. Okay, because the variable has got unformatted data stored inside of it. There are no tabs. But when you get the results out directly using a command would be taking care of formatting it on the screen on screen for you. Whereas the variable would be holding the stream of data directly from the command. So backtick operator is used for executing the commands internally within the shell script. All right, and the data you could use to operate on that data. So you could maybe store it inside a variable, or you may not even be interested in throwing that result out. That's completely up to you how you want to deal with that problem. So if I say like this, just execute the command, it would be just executing that command and it will not, okay, it will just execute the command, it will not throw the output away on the screen. So what happened now in this case is, if you see here, it says line 3 backups command not found, and the backups is the first character here as the output. So when you executed that command, the command gave back some output, and this was the output. If I place this output as it is inside the file, it would be treating it as a command, right? Like this. So backups, it would try to execute the command called backups, but command backups doesn't exist. That's the reason we are getting the error there. Okay, so let's do one thing. We'll move to another topic here. You already know what backticks would be used for. The next topic here would be to read the user input. Another way of making the program more dynamic. We can pass the parameters, of course, but if we are able to take the user input and behave accordingly, that would make our programs more dynamic. So for user input, let's say we write echo, please type in or tell me who you are. Okay, and read the output. Now reading output is done by another utility. Now again, read and echo are not the keywords here, they're utilities. Read anything that the user types into a variable called name. Okay, that could be anything. Then we echo out hello comma dollar name, right? So that's only one word at a time. It says tell me who you are, I say this is me, it gives me hello my name. What if I type two words? It would give me back two words. Okay, but you know that whenever you type a line or pass the arguments as a line there on to the script, every word is broken down into one single parameter. And if you're willing to take the input like that, you'll have to provide those many holders inside of it. What I meant is, tell me who you are, it would be expecting two words, f name and l name. Okay, so now it is expecting two words instead of just one. So let's do one thing, print them up. I would say f name and l name, first name and last name. Okay, now save it, execute this. Tell me who you are, so I say I am this. It gives me similar output, but to check whether it actually does that, we will use lname first and fname later on, so that we know that these variables are holding correct values. It should give my surname first and then my name. So there it is, giving me the surname first and the name later. So read would be taking the data from the console, and what is format of the read values that is storing that it is storing by default? It's string. How do you convert that into integer? I'll come into that later on. If you want to get an array, because you're not maybe you don't know how many words the user is going to type, so in that case you'll have to be ready for all those kind of stuff. So let's say if you say tell me your favorite colors, and you don't know how many favorite colors the user has, so it's always a good idea to take it all into an array. So I would say minus a, which is a parameter that you pass to the read command, minus a for array, and store it into a variable called colors. Okay, so colors here is an array that would be holding all the values. So to print all the values, we say something like this: your favorite colors are, okay, are what? Are all of the elements. So all of the elements can be written by the name, square brackets, and the @ sign. That means all of them. And I also need count of it, so I would say count here slash colors. If you do not mention @ sign here, it would only count one single element. It would give the count as 1. So it would say your X favorite colors are and the X values. Go save it. Try to execute it again. Tell me your favorite colors. So I say my favorite colors are red, yellow, indigo, violet, and so on. It says your 4 favorite colors are whatever you have typed. It's not concerned about the values, rather it is only dropping in all these uh, data that is stored inside those array elements. In bash, there is one important thing before we jump to the detailing of how to use the if-else constructs. Whenever we try to build a code as a service or as a daemon, the code would be running in the background, and there are multiple things that the user could do to that particular script. They could pause it, run it, kill it. Okay, so while killing the script, you already have got access to some heap data. So let's say this is my code, and the code is running a server in the background. So there is a daemon that I'm running. Okay, so the daemon code is using some internal variables. It has got some external files that it is trying to access, and the files are open inside this program. Okay, so how do we deal with this problem? If someone kills the program directly, in that case the variables would be lost, the external files might get corrupted. So if you want to handle the signals that the user is passing to you in an elegant way, the way to handle those signals is called bash trap. Okay, so the bash trap works in this fashion, where we write a trap function. Syntax is like this: keyword trap, trap is a keyword here, and then we write the function name. So I want to handle the signal called control C, so I would say trap the kill signal. Okay, trap the kill signal, and the kill signal is of type int. There are multiple signals which you could pass to a particular command. Control C would pass you sigint, sigint. I'll show you how many of them are present actually. There's a long list. So how do we define kill signal? Simply write it like this: kill signal. Now parenthesis is important, and like this. Okay, there's a difference between the trap functions and the general function. Trap function does not expect any of the parameters but has a parenthesis. General functions can expect a parameter list, but they do not have a parenthesis after their function names. Moreover, they have got a keyword called function associated with them. Here in bash trap, we don't. So here I would simply echo or do some house cleaning activities like releasing the pointers, so saving the variable values somewhere else so that we could take up the things from the next time onwards. anything that you want to place, but I will just place the echo statement just to identify whether the signal was trapped here or not. Okay, now you could decide whether you want to exit from that script or not. It's all up to you. If you don't place exit, then the script would go on for indefinite times. How do I convert this script into infinite script? Now let's see a little bit about loops as well. Okay, so I'm writing a loop for typing, or rather, okay, for typing 10 numbers, for printing 10 numbers on screen. So it would be like this: for a in seq. Backticks would help me to fire this command. Seq is a command from 1 to 10. So execute this. The loop body always starts with do, ends with a done. Function body starts with a curly brace, ends with a curly brace. Loop body starts with do, ends with done. Control structure body starts with then, and they would be ending with the reverse keyword. Not as in REVERSE, but if you're using if, then it would be ending in phi. If you're using case, then it would be ending in ESAC, and so on. Okay, let's print this. I want to, sorry, not print, it is echo $A. Simple. And since I wanted this to be taking some time, I would say please sleep for 1 second in between. Now I'm executing this. So this script would be giving me 10 numbers. Next time I execute it, I will also try to hit a control C in place. So I'm typing control C now. It says control C detected. It did some housekeeping activities and killed itself. If I don't write exit 0 or comment it out, in that case, my script will not kill itself even if I hit the control C button. It will proceed till the execution finishes and do nothing on the control C or the SIGINT. Let's see how many different signals are available there. I need a utility called htop to show you the signals. Apt-get install htop. So here htop is now installed. Htop, if you bring it up, uh, I'm sending a kill signal to one of the scripts here, and if you see on the left hand side, you have got all the various signals which are present from 0 to 31. Okay, so 0 is not a signal, rather from 1 onwards there are multiple signals which are present here. So if you're passing int, it is SIGINT here, signal type 2. Control C would pass SIGINT. If you want to handle any of the other signals, like if you want to handle SIGTERM, the terminals, the terminating signal that operating system passes to its processes when it shuts down, okay, or reboots. In that case, you could handle SIGTERM as well if you want to. So instead of int, you would be writing term, T-E-R-M. It's all up to you what you want to handle. You could also create multiple trap signals and write multiple functions for doing all your housekeeping activities. So we have seen arrays, right? But we haven't seen how to iterate over the array. Now, since we have already started the looping part, let's use the loops to do some fancy things. Very first would be looping over an array. So let's define an array here. I have an array that would be holding some values. We've already seen how to define an array using the read statement, that where whatever input is coming in, how to fit that into array. There is another one called declare minus a and the array name. That also declares the array. Okay, but now I want to declare an array which is called a white space array, a different form of array in which all the elements that you write would be separated by white spaces. So here in this array, if I write something like this, ABC, X, Y, and Z, then M, N, O, P, Q, R. So ABC is one element, XYZ is another element, MNO to R is yet another element. Since it is contained inside a string, this white space will not be considered for separating the elements here. If I want to loop over this array, now we are not using the sequences, we would be using the general for structure. Mind the parentheses, they are mandatory, otherwise it will not work. The reason why it wouldn't work is we are here setting up or using the variables without dollar signs. So I here is without dollar sign. If I use I plus plus, I would not be placing any dollar sign here as well. Okay, and everything should be executed as expressions. So I told you earlier that whenever you want to specify that this particular variable should be treated as an expression and not as a string, you'll have to do something. Those some things are like this. This is one way of doing it, dollar and parenthesis, or you place two parentheses, that's another way, or you place the expression within square brackets, that's third way of doing it. So I'll be using all these three ways in interchangeable fashion so that you get to know all the different formats of it. So in this case we are using double parenthesis. The syntax for is initialization, expression, and then increment or decrement. I want to initialize it, but first I need to get the length of the array. So length of the array is len equals to give me length of the array, which would be given by dollar and curly brace and hash and array name with all the elements in it. Okay, so we would be doing for I is less than dollar length. Do done, echo the element from the array, but this time I want very specific element, not all of them. So what I'll do is I would simply write I inside of it. Now that's the index. Will it work? Hopefully yes. Three elements placed on three different lines. So in case of echo as well, it would be placing a new line character after the line by default. If you want to place escape characters in echo statement, in that case, echo is rather a command here. It's not a keyword. So if you want to escape something, you could be writing -e as a parameter to this. And then if you pass any um, escape parameters to that, it would be taking care of it. Otherwise, it will not escape the backspace or the escape characters by default. It will not do it. -e has to be present. So that's one loop, one kind of loop. Another one is we will talk a little about while loop. So in while loop, the syntax would be initialization be out of it, right? Then while and then expression, then do. Since it is a loop, do done would be enclosing the body. Okay, so what I'm going to do now is I just want to read some data from the file, and I would be storing that data inside a array. Then we will loop over the array and print all the data out. So in this case, we don't need any initialization. I just need a count variable and the array in which I am going to store whatever is coming in. So let's do it here. I need an array. So declare array arr. So here we are declaring an array called arr, and I want the file to be pulled up. There's another utility called count that I want to use. count equals to 0. Okay, I told you that if you write variable name equals to any value, that value is going to be always uh, as a string, but in this case I want 0 to be integer. So what I'll do is I will use another keyword called let. So when you write let count equals to 0, it would specify that 0 is actually of int type. So while the expression in our case is while read the line, where the line is coming in from, I would be redirecting the content from the standard input. So it would say please taking the parameters from $1. $1 is my first parameter. It could be the name of the file. So if I pass the name of the file directly to the loop can take care of reading the file for us. So bash is very strong at file manipulations and file operations. Here I'm not opening the file, I'm not closing the file, I'm not worried about what it has. While would be looping over the file line by line, would generate the line here, and then I'm going to store that line inside the array. So array, I'm not using the array again, I'm declaring the array at every single index. So the indexes are given by count, right? Count, and it should be holding the line. So I'm assigning the line value to the array at particular count. Now we need to increment the count also. So either I do it like this, or I do it like this, or I do it like this. It's all up to you how you want to treat that variable. So we have the array holding all that data. It should not give any, yeah, dollar is an ambiguous redirect. It does not have a $1 defined. So let's define one. Let's see password is the file from which I want to get the data. Fine. It is storing it into a variable called array, and I want to have the data out from that array. So how do we do that? I would be looping over that array now. So either I loop over the array or simply print all the elements of it. Anything would work. I would simply say a array and throw all the elements that are inside you outside. That's how it is. So it is actually printing the last line. There must be some problem with the count. It's not incrementing the count. Yeah, it's not, because I have messed up with the case. It should work now. Let's try it out. There it is. Okay, but there is no new line character considered into this, because when you read into a line, the new line characters are scrubbed off. But what we could do is, instead of storing that into array, we could actually just iterate over the file and try to read that file out. So I could let off this array. We don't need any arrays or counters. Don't need any print statements later on. So I would simply do echo line. So here I'm simply reading the lines from the file and throwing them out to the screen. There it is. And since your echo statement would be adding a new line character at end, we don't have to worry about the new line characters even. Now let's look at some constructs. So I'll be talking of if-else constructs here, that how do we make the use of if-else for our own purpose. We'll be talking of operators after that. So there would be binary operators, there would be comparison operators, arithmetic operators, and they are a bit different than in other languages, especially the comparison operators. We'll talk of it in a while. Before that, if-else structure, how does if-else work? We have seen two kind of loops rather. For loops in two different flavors, while loop here in two different flavors. There is yet another called until. Okay, let me take an example here. We have the target is to print the numbers. print 0 to 8 numbers. Okay, until loop is exactly opposite of while. While would keep on looping till the expression is true and break out of the loop as soon as it considers as soon as it gets the condition as false, right? It executes for the true statements. As soon as the condition turns out to be false, it breaks out of the loop. In case of until, it would keep looping till the condition is false. As soon as the condition is true, it will break out of the loop. Okay, so that's what makes it exactly opposite of while. So the while loop, if I want to print 0 to 8 numbers using while, I would do something like this. My counter would be starting with 0. So I would say while, use let for that, right? Then we'd say while $count is less than. I'll talk more about the comparison operators, but they are different. $count is less than 8, less than or equals to 8, right? Then do something. Do what? Simply echo the number out, which is count. Okay, that's fine. Does it work? It says line 6, 0, command not found. Yeah, messed up one thing again. I would use this using square brackets here for identifying the expressions. Expressions always has to go in double parenthesis or dollar parenthesis or in square brackets. So let's add it in square brackets here. So that's infinite loop. What makes it infinite is that I haven't incremented it. So let's do it. Let count equals to count plus 1. So this time we haven't incremented it using plus plus but using the let keyword. 0 to 8 numbers, all good. If I want to achieve the same thing in until, minus LE is actually less than equals to. Okay, so if I have to reverse the condition, I would be using the loop like this. Until, of course, let has to be 0. Let count equals to 0 again. Until the condition, what should be the condition here? Can anybody tell me? What is exactly opposite of less than equals to? Rest of the body would remain same. We are only interested in what the condition is going to be. So if the number is not less than equals to, it could be greater than, right? We want all the conditions to be false. As soon as it turns true, it would get outside the loop. So I would say check whether count is greater than 8. So as soon as the count goes greater than 8, greater than has to be mentioned like this, GT. As soon as the count goes greater than 8, in that case, it will not follow the loop, it would get outside of it. So both these loops should give me similar answers or exactly the same answers. So it is 0 to 8 for while and 0 to 8 for until loop. Okay, that's how you'd be working on the loops here. So the if else structure, it's very simple. Starts with if, then there's an expression, should be mentioned in square brackets. There has to be spaces before the square bracket and after the square bracket as well. So whatever demonstration I'm providing here, it is very critical when it comes to spaces. We cannot play with spaces here like we could do with other languages. So if expression semicolon is used to separate two lines. So if I don't want to place semicolon, then the other part, which is then, should be placed on yet another line. Similarly in case of while expression, if you don't want to place colon do here, what you could do is you could start it on the another line, do done. Okay, so here in case of if, you would be writing if expression semicolon then the body, and it ends with a reverse if. You could also have the else statement. In that case, it looks like this. tabs are not required. This is not a beautifully typed language just like Python. In case of the elif statement, you could write something like this. It is ELSI if, or elif. It is elif. The syntax would be elif expression, then keyword, and this. Okay, very similar to the constructions of if else that we have seen so far. Let's put it to a test. So I have got two numbers, num1 equals to 1. So if that is the number, I would say let num1 equals to 1 and let num2 equals to 2. I want to check whether the numbers are same or not. So I would be writing if. In expression we would be checking for the numbers, so I would say if number 1 is equals to minus eq, number 2, eq is for equality operator between the numbers. In case of strings, it is going to be equals to sign. We'll talk of this. Okay, don't worry about that. I'm just introducing a few new elements every time I take an example. Then if that's equals to, then echo equals, right? Elif $num1 is less than $num2, then we would say that echo less. Else, no expression this time, we would be writing echo greater, equals, lesser, and greater. How do you end the body? You simply write reverse if. Go save it and execute it. It says it's lesser. Okay, if I change the value to 5, it should jump to the later part. Okay, what about the first section? If you check for equality, that works as well. Okay, so in today's class section we have seen how to use variables, how to define variables, work with arrays, loop over arrays, different kinds of loops, if else structure. The next class we are going to learn about arithmetic operators. Okay, we are going to learn about the logical operators, arithmetic operations in different forms. There are different forms of arithmetic operations that you would be using. You would be learning more about file operations and file descriptors. You would be learning about what pipes are and putting them to use. Okay, so that's what we are going to learn in tomorrow's class. One more thing is about functions and parameters. So that would bring us to the end of the bash part. It doesn't have a lot of things to be put together, but just something that some new things rather that you would be keeping in mind that it is different in bash. Let me think of something else. Okay, yeah, there's a difference between single quote and double quote strings as well, so we'll talking of strings. So these are the things that we are going to cover in tomorrow's class. So I would request you to be ready with whatever we have covered so far, all right, so that we do not find ourselves lost when we talk of operations and operators tomorrow. So that's all from my side for today. If you have any queries or doubts, any questions, feel free to ask it. So in tomorrow's class, we would be learning Bash, and we would be coming to an end about uh, the scripting languages. Okay, the next thing is going to be more interesting. We would be covering Docker, which is one of the virtualization technologies, and after that the things gets more practical. We would be learning about Nagios, the performance tuning parameters, writing scripts all by ourselves, securing servers and setting up firewalls, some database concepts, and all this kind of fancy stuff. So I'm done from my side for today. I'll see you again tomorrow morning at 8 a.m. IST. All right, and continue with the topics ahead. Thank you so much for attending the class today. Have a great day ahead.